Good morning. Now, this is module 3, the second half of our module 3, experimental methods and error analysis. In the last class, we have completed the first half of module 3, which was about measuring instruments, right? Now, today we will start with the first class on the second half of module 3, which is about error analysis. So, here there is nothing much to teach. You can just read through. See, measurement. Let us see about fundamental units. Measurement of any physical quantity. We know that it involves comparison with a basic or an internationally accepted reference standard called unit. Okay, whenever you are asked to measure a physical quantity, and it's quite natural that in order to compare the unit quantity that you have, you have to compare it with the internationally accepted reference, and that internationally accepted reference standard is called a unit. Now, the result of measurement of a physical quantity is expressed by a number accompanied by a unit. That is, it will have a unit. Unit of fundamental or base quantities like length, mass, time are called fundamental or base units. Okay, what are fundamental or base units? We know that the basic quantities are length, mass and time, right? Now, the units of these fundamental or base quantities are called by the name fundamental or base units. Now, such units obtained for the derived quantities, they are called derived units. Now, these derived units and fundamental units, this complete set is called by the name a system of units. So, there are different system of units available. One is CGS system. C stands for centimeter, G for gram and S for second. Okay, you know that they are actually the respective units for measuring length, mass and time. The next is FPS system, that is foot, pound, second. Then MK system, that is meter, kilogram, second, etc. Now, at present, the internationally accepted unit of measurement is the SI unit. And on that is, it is also called by the name International System of Units. Now, there is a table showing various base quantities like mass, its unit is kilogram, its dimension is m, then length meter, time second. These definitions, actually I'm not explaining all these things because I'm just presenting this table here. So because it is very simple, you can read from the text. Then the other base quantities, temperature, its unit is Kelvin. Then amount of substance is mole, electric current unit is ampere, then luminous intensity unit is candela, etc. So here they have given a few base quantities, its unit, its dimension and the definition. So this I think you can read from the text. So along with this video I will upload as before the full notes on error analysis. Okay, so you can read from that text. That is enough. Then about error analysis, we all know that error actually it is not a mistake or blunder. That is the first thing that you should understand. If we make an error, actually it is not a mistake or blunder. Instead, we can say that an error is actually an uncertainty or imprecision in the measurement. So imprecision means inaccuracy. That is, that inaccuracy in measurement may be either due to the inaccuracy of the instrument that you use to measure the quantity, or it may be due to the inability of the experimenter to take the proper measurement. So this inaccuracy or imprecision in the reading that you have taken can come from any of these, either due to the inaccuracy of the instrument that you use to measure, or either due to your inability to take the readings properly. So error is unavoidable. In every measurement you will have an error, but this error is not a mistake or blunder. Instead, an error can be treated as an uncertainty or imprecision in the measurement. Okay, that is what described in this paragraph. Then another thing that is described here is that in order to determine the accuracy of a particular measurement, that is, suppose that you have measured something, and in order to understand how correct the value that you have measured, what you need a true value, right? That is, you must have a knowledge about the true value that you should obtain after performing this experiment. Then only you can understand how far your measured value deviates from the actual value. So you must have a knowledge about the true value or the ideal value. Okay, that is what written here. Sometimes we have a measured value which is not precisely, and we assume that this is our ideal value, and we will use that value to estimate the accuracy of our result. Okay, other times we know a theoretical value which is calculated from basic principles. Okay, that is that theoretical value or the ideal value, true value, you must have a knowledge on that. Then only we can estimate the accuracy of the result that we have obtained. Now, the main purpose of error analysis is to check whether the result of experiment agrees with a theoretical prediction or results from other experiments or not. Okay. So, generally speaking, a measured result agrees with a theoretical prediction if the prediction lies within the range of experimental uncertainty. So, before starting an experiment, you must be aware, you must be at least aware of the true value or ideal value that you should obtain. Then only you will be able to estimate the accuracy of the result that you obtain from the measurement. Now, what is accuracy and precision? Okay, accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity. It is expressed as percentage difference, that is experimental value minus true value by true value into 100, that is accuracy. Now, what about precision? It gives us an idea about what resolution or limit the quantity is measured. It is precision is the agreement among several determinations of the same quantity. So the better the accuracy or the better the precision, lower will be the difference among the values. Okay. So if you need high precision for your result, then you have to do the experiment with a good carefulness. That is, you have to do a careful work. Then only you will get your result in high precision. If a measured value has a high precision but poor accuracy, then an error called systematic error is likely to have. Whereas good accuracy and poor precision can result from a combination of unsystematic measurements or lack of instrumental resolution. So in this paragraph, you need to study only about the definitions and the mathematical expressions for accuracy, and then you have to study the definition for precision. See, from this you will have a knowledge about, you can, from these figures you will understand the difference between accuracy and precision. In the first figure, it is low accuracy, low precision, that is the arrow is sitting at various different points. Whereas in second figure, there is high precision but accuracy is less. Whereas in third figure, there is low precision but high accuracy. Whereas in the fourth figure, everything is concentrated at a single point, right? So it is of high precision and high accuracy. Next is sources of error in measurement. The result of every measurement by any measuring instrument contains some uncertainty. This uncertainty is called by the name error. Okay, errors are inevitable. That is, we cannot avoid error because in all experiments that you perform, as I said before, there will be an error. Thus, every measurement is approximate due to errors in the measurement. So, errors in measurement are classified into two: systematic and random. Now, what are random errors? Random errors are always present in an experiment, and in the absence of systematic errors, they cause successive readings to spread out to spread about the true value of the quantity as shown in figure A. This is the first figure. That is, you have an actual quantity there, and the readings that you take in the measurement will spread about the true value. They are spreading about the true value of, so that is the systematic error. Okay, that is called random error. Now, if in addition to the random error, if you have a systematic error, then how will the readings look like? The readings will spread out. Here also, the readings that you take will spread out about the true value, but it is not spreading about the true value. Instead, they are displaced at a very long way from the true value. In the first case, the values that you measure or the measured value are spread about the true value. That is in the case of random error. Whereas in systematic error, the measured value will spread not about the true value but about some displaced value. That is the difference between systematic error and random error. So here you have to study the difference between systematic error and random error. Now systematic error in detail. Those errors, they tend to be in one direction. It will be either in positive or negative direction. One is personal error. As the name suggests, it is the error that arises due to the mistakes of the experimenter. It arises due to an individual's bias, lack of proper setting of apparatus, or individual's carelessness in taking observations, or without observing proper precautions. Now that is the definition for personal error that you can read. Nothing much to explain, they are written in very simple way. Now how can you minimize personal error? That is by performing the experiment by several persons and taking the mean of the results. That is how you can reduce personal error. So in all error you have to define each of the error, and you also have to mention how it can be reduced. Next is instrumental error. As the name suggests, it arises from the error due to imperfect design or calibration of the measuring instrument, like zero error in the measurement, limit of resolution of instrument, etc. So when you are measuring it with a vernier caliper or electronic balance or electronic meter, we have to always check the zero reading first. Okay. If it is not exactly pointing at zero, then re-zero the instrument if possible, or at least measure and record the zero offset so that readings will be corrected later. So check whether the needle stands at correct zero, then only you can start the experiment. If it is not at stands at correct zero, then you will have to re-zero it. If you are not doing it, then that particular error, that will be a constant value, and that will reflect in all your readings. So your readings that you get will be wrong. Then imperfection in experimental technique. It actually arises due to imperfection in conducting experiments, experimental procedure, etc. Now parallax error, it occurs whenever there is some distance between measuring scale and indicator used to obtain a measurement. Now if the observer's eye is not aligned with the pointer and scale, reading may be too high or low. Okay. Then systematic errors altogether can be minimized by improving the experimental technique or by selecting better instruments and removing person's bias as far as possible. So these are the various systematic errors, and they have suggested the various ways of eliminating systematic errors. So this is very important, systematic error. Next is random error in detail. So random errors are those errors that tend to be in two directions. That is, it will occur in both positive and negative directions. So that is the definition for random error. Now it is arising, or it is due to random and unpredictable fluctuations in experimental conditions. Okay, that is the reason for the occurrence of random error. That unpredictable variations can be either in that case of temperature, or in the voltage supply, or mechanical vibration, or experimental setup, like that. For example, least count of instrument also comes under the random error category. All these random errors, we can minimize it by repeating the experiment a large number of times. Okay. So as I said, it can be either positive or negative. So by taking the arithmetic mean of the measured quantities, we can these errors will get cancelled, and after that you just take the mean. Okay, then that mean value will be almost close to the true value that we are supposed to get. Okay, so in order to avoid this random error, you can also use various instruments of higher precision, or you can use very improved experimental technique also. Okay, so here they have discussed about the given an example for measuring the time period of a simple pendulum by means of stopwatch minute times. Here one possibility of occurrence of error while you are taking the period of simple pendulum is that there will be error while you start the stopwatch. Similarly, there will be error while you stop the clock. So all these errors are will be reflected in your result, and they are counted as random errors. Okay. So depending upon that error, you will get a value, a very long value or a very short value, that is a high value or low value. So you must have an idea about, as I said, about the true value that you get. Okay, so this random errors, there is another definition. They are statistical fluctuations in the measured data due to precision limitations of measured device. Okay, that is, they can be evaluated through statistical analysis and can be reduced by taking the mean value or averaging over a large number of observations. So random error is also important. Then rejection of spurious errors. Errors which make the measurement ingenuine, that is not correct, are called spurious errors. They occur due to mistakes on the part of the observer or due to malfunctioning of the equipment. Okay, that is misfunctioning of the equipment. Then mistakes from the part of observer either may be due to his carelessness or individual limitations. So here also they have given an example. If the instrument that you are taken is not working properly, or if its preliminary adjustments are not done, then this type of error will come in, that is the spurious error will come in. Okay. um, Here if you measure the diameter of a wire using screw gauge, reading, see the reading 0.6 millimeter, 0.62 millimeter, various values will get if the instrument that you take is not properly functioning. So these type of errors are called spurious errors. Now, why you need to eliminate error, or is there any need for estimating errors? The manner in which an observation is recorded indicates how accurately the physical quantity is being measured. So the process of evaluating the uncertainty associated with a measurement result is often called uncertainty analysis or error analysis. Okay, that is, as I said before, whenever you are going to measure something, you must have an idea about the true value that you should get. Then only we can estimate the deviation of our result from the actual value. Okay, so proper reporting. So suppose that you get a result after performing an experiment, then you have to report the exact value that you got along with the uncertainty. That is, proper reporting of an experimental result along with its uncertainty is very important. That is, you are not supposed to record only the value that you get, you have to write the uncertainty also. If you get a value 5 centimeter, it can be either 5 plus or minus 2, either it can be 7 or it can be uh, uh, 2 digits greater or 2 digits lower. Then, so it will not be exactly 5. So 5 plus or minus 2. So that plus or minus 2 is actually the uncertainty in the reading. So while reporting your result, you have to write not only the correct result but also the uncertainty that is present in it. Then only the other people can take up the experiment, or then only they will be able to judge about the quality of your measurement, or then only they will be able to compare it with the results that is already measured. So every time when you report your value, you have to include the uncertainty also. That uncertainty is reported just to make judgments about the quality of the experiment. At the same time, it also helps others to compare your result with the similar results. Okay, so this paragraph you can just read through. They were asking some questions, and so just read through this paragraph. So thus we have come to the conclusion that in any measurement decreases with the decrease in least count of measuring instrument. It is also clear from the manner of recording the observations, the accuracy of measurement can be judged. So just go through this paragraph. Now this is very important, absolute and relative error. Suppose the values obtained in a measurement are a1, a2, a3, etc. up to an. Then arithmetic mean of the values is taken as a1 plus a2 plus a3 up to an by an. So summation from I equal to 1 to n ai by n. So the magnitude of difference between the individual measurement and the true value of the quantity is called absolute error. That is, delta a1 will be a1 minus a mean. You are minusing each of this value from the mean value that you obtained. So absolute error, in short, you can write it as delta n equal to modulus of an minus a mean. Now arithmetic mean of absolute error will be delta a mean equal to delta a1 plus delta a2 plus delta an by n. Relative error is defined as ratio of absolute error, that is delta a mean to the mean value of the quantity measured, a mean. Okay. Percentage error is relative error into 100. So in this session you have to study about various errors: systematic error, random error, relative error, percentage error, absolute error, then relative error, or their definitions and expressions. Then this paragraph you have to read through. Then what are spurious errors, all these things. Okay, random error, then what are the various types of systematic errors, what are systematic error and random error, then what is precision, what is accuracy, Then what is error? Okay, now this paragraph, no need of by hearting this table, you can just read through it. Okay, then what is fundamental unit, what is derived unit, and what are the different types of units. Okay, so please read through it. It's very simple. When you read through it once, definitely you will understand, because they are written in a very simple way. That's why I'm not explaining it much. Okay, thank you.